Hello, today we're working on solving systems of equation using multiplication. It's still elimination, but this time we're using multiplication to help us with eliminating one of our variables in our systems. Okay, so we have our first one here. We know that sometimes when we eliminate, we need to find the opposite of each other, or if we're adding, and if it needs to be the same if it is subtraction. And sometimes to do that, we need to multiply by the constant so that when you're adding and subtracting, you can eliminate that one variable. So we're going to look at our first example here. We have 2x plus 10y equals 2, and 3x minus 5y equals negative 17. And when I am looking at those and I look at my x's, it's showing me that I would have to multiply by both to be able to get something that's going to work. If I look at my y's, I have a 10y and a negative 5y. Well, this is something I can work with. If I multiply negative 5 times 2, I would get negative 10. And so if I take positive 10 plus negative 10, I would eliminate that. So I'm going to multiply this second equation by 2. And when I do that, I'm talking about multiplying the entire equation by 2. So that's why it has parentheses around it. So 2 times 3x gives me 6x. 2 times 5y gives me 10y. And 2 times negative 17 gives me negative 34. Now, when I bring my other equation, 2x plus 10y equals 2, and I line it up with my new improved equation here, I am going to be eliminating my y's. So that's gone. We now have 0 y's. 6x plus 2x is 8x, and negative 34 plus 2 gives me negative 32. So now that I have 8x equals negative 32, I divide by 8, and I get negative 4. So I'm going to put my negative 4 for my x here. Now I'm going to use that negative 4 and I'm going to find out what my y is. So I'm going to take my 2x plus 10y equals 2, and I'm going to place my negative 4 in place of x. It really doesn't matter which equation you use, just as long as you're using one of the original equations. That's what's important. And so I have negative 8 plus 10y equals 2. I'm going to add 8 to both sides and I get 10. 10y equals 10, divide by 10, I get 1. So my solution to my system is negative 4, 1. And again, you can pick any of the options that we've used in the past. You can plug in the options to both equations to know if they work. You can find the x-intercept and the y-intercept, whichever works for you. As long as you can prove that those work, you're more than welcome to do that. We're going to practice with multiplying and adding. So we're going to take a look at number 4 first. And I'm going to move it and enlarge it here. So I've got 5x plus 2y equals negative 10. And then I have 3x plus 2y equals 66. And when looking at these, I see that this would be a little more difficult to work with, but this is doable. If I take 2 times 3, I get 6. Because I need them to be opposite because I'm supposed to be adding, I'm actually going to multiply this by negative 3. So I'm going to take my 5x plus 2y equals negative 10, and I'm going to multiply the whole thing by negative 3. And remember, that's because I need this to be a negative 6. So I'm going to have negative 3 times 5, and that's going to give me negative 15x. Negative 3 times 2, and that gives me a negative 6y. And a negative 3 times a negative 10 gives me positive 30. Now I'm going to write my other equation directly underneath it. So I have my 3x plus my 6y and equals my 66. And we're going to be adding these. So my y's cancel out, they're gone. And negative 15 plus positive 3 gives me negative 12x. And 30 plus 66 gives me 96. Negative 12 goes into 96. 8 times negative 8. So my x is negative 8. Now I'm going to substitute x as negative 8 in either one of these. I think I'm going to do this one. So 3 times negative 8 plus 6y equals 66. That's negative 24 plus 6y equals 66. And if I take and add 24 to both sides, I get 6y equals 90. Divide that by 6, and y equals 15. So there's my ordered pair solution to my equations. Let's take a look at the next one. I have 4x plus 2y equals 6, and I have 3x minus y equals negative 8. And I need to determine which variable I'm going to eliminate. If I look at my x's, I have a 4 and a 3, not as easy to work with. I look at my y's and I have 2y and a negative y. This is something we can work with easily. If I multiply this equation by 2, I would get a negative 2y, and I can easily add the positive 2y to a negative 2y to get rid of them. So I'm going to take my 3x minus y equals negative 8, and I'm going to multiply them by 2. Now I'm going to take my other equation and I'm going to write it below it. And we're going to be adding these. So these cancel out, no more y's. 6 plus 4 is 10 x's. And negative 16 plus positive 6 is negative 10. X is going to equal negative 1. Now we're going to substitute negative 1 into our equation. Let's do, let's do this one. 3 times negative 1 minus y equals negative 8. That's negative 3. Add 3 to both sides. And divide by negative 1 to change y to a positive. And y equals 5. Take a look at number 6. Which one would you choose to change so that you can eliminate? If you chose the 9s, that's the one that I would choose. I could multiply everything down here by negative 9. Another option that I saw are these x's here. And I'm actually going to do the x's instead of the y's because I want to show you solving for a y first and then an x second. So let's go ahead and eliminate our x's. So if I have a negative 6x here, if I multiply this by a positive 3, I get a positive 6. So we're going to take our 2x plus y equals 0, and we're going to multiply that whole thing by 3. So then I get 6x plus 3y equals 0. And now we're going to write our other equation right below it. And we're going to add. So my x's cancel out. 3 plus 9 is 12. So we get 12x. Or sorry, 12y. And 0 plus negative 12 is negative 12. Divide both sides by 12, and we get negative 1. In this case, our y is our negative 1, so we need to make sure we're placing it in the y portion of the solution. Okay? Now we're going to take and substitute in for a negative 1, and I'm actually going to use this one here. So we have 2x minus 1, because y is negative 1, equals 0. If I add 1 to both sides, I get 2x equals 1, and divide by 2, I get x is 1/2. So my x in my ordered pair is 1/2. Sometimes when we do our multiplication, we can also do subtraction from it. Okay, and so we just do the same thing. We look to see what works and what doesn't work. When I look at these, I see that my x's are easier to change, and so I am actually going to multiply the second equation by 3 to make it a positive 6x. Because I'm subtracting, I want the signs to be the same. Okay, let's go ahead and practice a couple. We have 7, 8, and 9 here. Let's look at number 7. So 7 has 3x minus 7 equals 2, and 6x minus 9y equals 9. I'm going to make the change for my x's. 3 times 2 is 6, so I'm going to do that. So we're going to multiply everything by 2. And that gives me 6x minus 14y equals 4. And now we're going to add our 6x minus 9y equals 9 right below it. And remember, we're subtracting. 6x minus 6x, that's 0. The x's are gone. And now we're going to solve for our y. One of the things to be very careful of is make sure that you are reading this correctly. We're taking negative 14 minus a negative 9. And that's going to give me a negative 5y. You can also do keep, change, change. So we're adding a positive 9 to a negative 14. That's a negative 5. And 4 minus 9 is negative 5. And so divide both sides by negative 5, and we get y is 1. Now we're going to replace y with 1 in one of these equations. So let's do 3x minus 7 times 1 equals 2. And we get 3x minus 7 equals 2. Add 7 to both sides, 3x equals 9. And divide both sides by 3, we get x is 3. So our ordered pair is 3, 1. Take a look at number 8. We have negative 3x plus y equals 11. And then we have 2x plus 3y equals a negative 11. When I look at my x's, I would have to change both. If I look at my y's, I only have to change the 1. Because it's subtraction, I want to make sure that that's a 3y, not a negative 3y. So I'm going to multiply this entire thing by positive 3. So we're going to negative 3x plus y equals 11, and we're going to multiply by positive 3. So that's negative 9x plus 3y equals 33. And then we're going to write below that our other equation, which is 2x plus 3y equals negative 11. And we're subtracting the entire thing. So 3y minus 3y, that's 0. It's out. Negative 9 minus 2, keep, change, change, is the same as adding a negative 2, so that's going to be a negative 11x. And 33 minus a negative 11 is the same as adding 11, and that's going to be 44. Divide by negative 11, x is going to equal negative 4. Now we're going to substitute x with negative 4. So let's take negative 3 times negative 4 plus y equals 11. That's 12 plus y equals 11. Subtract 12 from both sides. Y equals negative 1. And there's your ordered pair. Take a look at 9. What do you see needs to make a change? Remember, we're subtracting. Okay. Did you pick the x or did you pick the y? If you pick the x and we multiply this by positive 3, we can eliminate our x's. If I picked the y's, then I would have to multiply this all by negative 2 to be able to eliminate the y's because we're supposed to be subtracting. Okay? So I chose to change this one to a positive 9 by multiplying by 3. So I'm going to take my 3x minus 2y equals negative 11. And we're going to multiply everything by 3. So I found that my y is 6 because I was able to cancel out my 9x's. And negative 6 minus 1 is negative 7y. And this would be negative 42. I got my 6. Then I plugged in my 6 on the first equation. And so when you subtract, you get 3. Divide by 9, you get 3 over 9, which is the same as 1/3. And there's your x. Okay? We can also use this to solve problems with systems of equations. We're actually going to go ahead and go to the your turn example and work it through. Just like before, we have two variables. We have an x and a y, and we have to determine or identify what our x's stand for and what our y's stand for. So it says contestants in the run and bike-a-thon run for a specified length of time, then bike for a specified length of time. Jason ran at an average speed of 5.2 miles per hour and biked at an average speed of 20.6 miles per hour, going a total of 14.2 miles. Seth ran at an average speed of 10.4 miles per hour and biked an average speed of 18.4 miles per hour, using the total of 17 miles. For how long do the contestants run and for how long do they bike? And so I'm going to use the amount for running is my x, so as that's my run, and y is going to stand for my biking. So for Jason, I need an equation, and I need an equation for Seth. So this is my equation for Jason. This is my equation for Seth. I see that I can eliminate my x values. If I subtract, I can just multiply this by 2, and I would get to 10.4. So I'm going to change this to its doubled version. I'm going to show my work down here. Once I've doubled it, I got 10.4x plus 41.2y equals 28.4, and then I brought Seth's equation down and layered it underneath. And we're going to subtract those. So I have no more x's, and then I have 41.2 minus 18.4, and that gives us 22.8y. And then 28.4 minus 17 gives me 11.4. So now I'm going to divide by 2, and y would equal 11.4 over 22.8, which is the same thing as 1/2. Okay, so that means that y would be, since y is the biking, that they biked half of a mile, or half an hour. So biking is 1/2 per hour. So 1/2 mile per hour. For running, I would replace the y with 1/2 and solve for x. And when I do that, I actually use the decimal so that it make it easier. And so I get 41.2. So I got 5.2x plus 41.2 equals 14.2. I'm going to take 14.2 and I'm going to subtract the 41.2, and I get negative 27. And then I'm going to divide by 5.2, and that gives me not right. Hold on. I accidentally divided instead of multiplying by 0.5, so that that was my error. So it's 5.2x plus 10.3 equals 14.2. And 14.2 minus 10.3 is 3.9. So I have 5.2x equals 3.9, and divide by 5.2. And that gives me 3/4 or 0.75. Let's do, so running was 3/4 of a mile per hour. Okay. If you have any questions, please make sure you're talking to your teacher. When you're writing these equations and then simplifying, it can get a little tricky. So make sure you ask good questions. Thank you.